Hello, I'm Navneet.
And I'm Harsha, and we'd like to present our project, SeDeNN, a self-driving car using deep neural networks. Self-driving abilities are already deployed in commercial vehicles like Waymo and Tesla, but the problem is that the technologies they use are proprietary, custom-made, and expensive. Examples include the Tesla's onboard computer and Waymo's proprietary software for self-driving. For reference, the image in the bottom slide is the Tesla's computer. So we want to change it by a solution that is cost effective, open source, yet works like the real deal.
Related work. A lot of work has been done around self driving cars. Paper 7 is the closest work to our project. They only used a Raspberry Pi without any accelerator and implemented only one neural network for steering the car. We take it further by running two neural networks on a Raspberry Pi along with a Coral TPU to achieve self driving capabilities in real time.
Our approach involved three important stages: hardware, software, and testing. As mentioned earlier, for our hardware, we use Raspberry Pi 4B as our embedded computer and a Coral USB accelerator in order to accelerate our deep neural networks. We use SunFounder's Pi Car 5 for the car. It came with a Raspberry Pi hat to control the wheels and the steering.
The software involved creating two neural networks. First neural network is based on PilotNet. It is used to steer the car by detecting the lanes. The top layers were frozen and the last two layers were trained for our custom dataset. The second neural network is based on STD MobileNet v2. It is used to control the acceleration and braking by detecting traffic signs and pedestrians. We obtained the dataset for this model by taking images of of traffic signs and human figures, and then we used Pascal VOC format to label these images. Post-training quantization to 8-bit integers reduced our neural network size by 53% in MobileNet v2. We tested both the neural networks individually, and the results were 99% accurate at detecting objects and 70% accurate at lane detection. Challenges. One of the biggest challenge we faced was creating our own custom dataset to train the neural network and label each image using Pascal VOC. The second problem that we faced was deploying the DNNs on a Raspberry Pi and Coral TPU and get real-time results. The third major challenge was testing the car, where we had to create a completely new test track to see the performance.
And from achieving these challenges, we ended up with the following results. We collected and labeled custom datasets on which we trained and tested our neural networks. We applied techniques like post-training quantization to compress the weights to 8-bit integers and generated TF-Lite files to run it on the Raspberry Pi. We inferenced it on real time on a Raspberry Pi with satisfying result. We were able to achieve our goal of self-driving car that can look at the pedestrians and respond while staying in the lane. And finally, here is the demo for our project. Thank you.